We're now going to have a look at expanding bracket by bracket, whose expansion is the difference of two squares. Now we're going to look at a longer method and a shorter method. We're going to do the longer method first, where we expand using the usual procedure, where we have x plus 5 times x minus 5, where we go x times x is x squared. X times minus 5 gives minus 5x. 5 times x gives plus 5x. And plus 5 times minus 5 gives minus 25. Now we collect the like terms of minus 5x plus 5x. They will cancel out and we get a result of x squared minus 25. Let's follow the same procedure with the next one here. We have x times x gives x squared. X times plus 3 gives plus 3x. Negative 3 times x gives negative 3x. And negative 3 times plus 3 will give negative 9. Now we collect the terms of plus 3x minus 3x. They will cancel out and we're left with x squared minus 9. Now can we use a shorter method to get our expanded expression? If you have a look here, you'll notice the first two terms in each of the brackets are the same, x, x. And the last two terms are the same in as far as we have 5, 5. But the signs are different. Here we have a plus, here we have a minus. Now it's the same pattern here in the next one. We have an x, x, the same, the same. We have a 3, 3, the same, but the signs are different. Here we have a minus, here we have a plus. Now when we have this situation, you will notice that the two middle terms will cancel. So the middle terms of the expansion always cancel in these circumstances, and we're left with two terms in our final result. Same thing here as well. The two middle terms here will cancel. We have two terms in our final result. Okay, let's use the quicker method here now, where we have a plus b times a minus b. Now this will give us our general formula. So all we now do is just multiply the two first terms and get a times a squared. Multiply the two last terms, we get plus a times minus b gives minus b squared. And that there is our general rule. So let's apply this idea to these examples. We have x plus 7 times x minus 7. So all we do is multiply the first two terms together and we get x times x, x squared. Now we multiply the two last terms together and get plus 7 times minus 7 gives minus 49. Now the reason why we can do this is because you can see the pattern. Same, same, first two terms, same, same, last two terms, but the signs are different. The next one, it's the same again. So we just simply go x times x, x squared. Negative 10 times plus 10 gives negative 100. So now the next one. Again, you can see the result will give a difference of two squares. It's the same, same, but the signs are different. So we just multiply the first two terms, where we get 3 times 3 is 9, x times x, x squared. Now we multiply the two last terms, plus 1 times minus 1 will give minus 1. Number D. Again, you recognize the result will be a difference of two squares, so we just multiply the first two terms together. So 4x times 4x will give 16x squared. Now we multiply the last two terms, we get minus 5 times plus 5 will give minus 25. Now that's how we expand using a difference of two squares as the result. before we finish, let's just have a look at why we call this a difference of two squares. Let's just analyze the results here a little bit more carefully. I can isolate the x there, x squared, and I can isolate this 25, and I can rewrite this as x all squared minus 5 all squared. Now there is our difference. That's the difference, the minus sign, of two squares. That's one square. That's our other square. It's the same thing here. If I rewrite this as x squared minus 3 all squared, as you can see, there is our difference of two squares. There's our difference, the minus sign, and our two squares are x all squared and 3 all squared. That's why we call the result a difference of two squares.